Hi, my name is Tianle Liu. I'm here to do the homework 2, problem 5 of the probability course. And you can see the share screen on my monitor. So let's do that. So for this problem, we know we are dealing with the Poisson process. We already have the formula, and already have one condition. So for first one, we need to find the lambda. For this lambda, we already have that the probability that in 2 minutes at least one customer arrives equals to 0.3. So we can list the t is equals to 2 minutes and it's at least one. By the probability, we can know that it's equal to 1 minus probability of the 2 minutes that there are no people arrive at the store. So we can bring it back to the formula. We can have 1 minus e the and then there's 0, which is equals to e minus e to lambda. And this one is equals to 0.3. So do the calculation. And we can have the lambda equals to ln 0.7 over 2 with the negative signature and negative sign. And we can use the calculator to do the calculation to run it up for the further calculation of the parts. And it's run it up by the 0.178. So we already solved the lambda, but actually this lambda is quite complicated. So we will use the lambda first, unless we are calculating the last step of each one, each part next time. So for this one, for this part, for the next part, we will find the probability that in 3 minutes no customer comes. So we just need to modify this one. Sorry. Probability of the 0 to 3, t is equals to 3, k is equals to 0, which will be e because whatever the lambda and t is with a power of the 0, it will equals to 1, and the factorial of the 0 is equals to 1, so it will be e with the power of the negative 3 lambda. I will do the calculation using my calculator. Which is rounded up by the 0.586. So find the probability that in 10 minutes at least 2 customers will arrive. So just list it out. We have the t equals to 10, and we need to make the k is greater or equal to 2. So in the probability, like the complement we can know that it is 1 minus probability of there are no customer arrive in 10 minutes, and the probability of only one customer arrive in this 10 minutes. So do two more calculation using this one. This one is quite obvious. It's the e with the power of negative 10 lambda, because the k is equals to 0. But for the next one, we should have the e negative 10 lambda, and let's see the formula. The factorial of k, which k equals to 1, is still 1, but we now have to multiply by the lambda t. Lambda t is the 10 lambda. So to do the calculation, we will do like this. Negative 10 plus 0.08. Okay, minus one more, which is the negative 10 multiplied by 108, and multiply by 10 multiplied by 108, which is rounded up by the 0.531. Okay, so for this problem, we just need to follow the problem part to see what is the t represent to and what is k represent to. So for the last part, it's not that difficult. It asks for the 1 minute exactly one customer will arrive. Quite easy. So we need to write the probability of the 0, 1 goes to 1, which is the t equals to 1, and k equals to 1. Lambda t is lambda, which is this one. So we will do the calculation here. Which is the quite small. Now we have the calculation. We can run it up by the 0.149. Okay, I think this is the answer of this question. Let's see whether there's any clues for this problem to check it with whether we did it right. I think there's no clue, but for this problem, I think it's quite easy to check just the, you already have the formula of the Poisson process. So you just need to fill it in and find the output of the process formula. That's not that difficult, but you need to make sure that whether there's at least the problem, you should to use the 1 minus the probability of the rest of parts, just like the problem part 1 or problem part 3. Maybe sometimes we cannot just calculate the at least, but we can use the exception, like just to accept the problem of like there's no customer for at least one. There's no exactly 0 customer or 1 customer for at least 2. and so on. That's some tips for this problem. So I think that's it for this problem.